exponential equations. Why is it an exponential equation? How do you see that it's an exponential equation? Because there are x's in the exponent. So when we do this exponential equation, we take the rule that says the bases are the same and keep the base, and we subtract the exponents. So we've got 2x minus x giving me x, and that stays minus 1. Now I didn't write that express thing in there that you show that it's 2x minus 1 minus x. I just did the answer. Is that fine? On the other side, we've got 3 to the power of 1. So we've got x minus 1 equal to 1. And you can even write the answer immediately there to say that x is equal to 2. How many marks? 1. Okay, because it's the principle of doing exponential rules and then exponential law of bases are the same, exponents must be equal to each other. So that should be around about 2 marks. Right, then number K, for getting to x, there's my x over there, but there's a whole lot of other stuff here as well. Which rules? What am I going to do here? So what will this be?
We have to
We can make thingy the 9, yes, 3 to the power 2, so that'll be 3 to the power 2 over 3, which isn't just an answer. It's not cube root of 9, that's 3, that's wrong. Okay? And on that side, what are we going to do to the 3 in the square root?
3.
Will be 3 to the power
2x divided by 2.
Are you with me? And then it'll be 2x over 2, or just x, because when we multiply, it's the top times each other, the bottom times 2x over 2, which will just give me x. So we've got 2 over 3 equal to x. My sum is finished. Definitely a mark for working it here from the root size to exponent that's rational. And there the same thing, from the root to exponent that's rational, and multiplying it in. So most probably 1 for each and then 1 for the answer, and we leave it like that. Number L has got something different. How do we treat a decimal? And that is? How did you get that? Calculator. Old school is to say 375 over 1,000, and then finding something that can go into the top and the bottom until I simplified it to 3 over 8. And then the 9 and the 6, oh well, I lost my x. I'm solving x and x is missing. Are you seeing this? Is it important that I still have the bracket there? Yes. Very important. Because it means 3 to the x and 8 to the x at the bottom as well. So you've got to keep the whole thing in a bracket. And then on this side we've got 9 and we've got 64. What do you think? Make them the same. Even if it's a fraction. If you can get both of those to be the same. Now 9 can be written as 3 to the power 2, right?
Yes.
And 64?
8 to the power 2.
Ah, excellent, going for 8. Usually we go for 2, right? Prime factors of 8, 2 to the power 3. Prime factors of 64. So how come you want to go for 8? Because you're very clever. Seeing what you should be seeing. I want these to look the same. So I want this 9 to be 3 square and 8 square, so that I can get to 3 and 8. Are you with me here? And that means I can put the whole thing to the power of 2. Because those are the rules. When you've got it on the outside, time it in. When they're both in the inside, take it out. So that I can see the principle of 1 power equals 1 power. Bases are both 2x. Even if it's not prime numbers, they're both the same bases and x is equal to 2. Would it have worked if you took it to prime factors of 2? Eventually, it would have, but it would take you a little bit longer. If you saw that you can get those bases both to be 3 and 8, you just did it a little bit easier. Still the question says?
Solve for x.
Solve for x, and I'm seeing exponential equation, so my brain is saying, I think there should be a 2 to the something with the x equal to 2 to the something. That's what I'm aiming for. Are you with me? But the problem in the sum is the plus. And the plus tells me? So how do I factorize? Hopefully, Always. Type number 1. Common factor. Is this common factor? Yes. Fantastic. Alright, so I take out the common factor. Do you have to write that step that says 2 to the x times 2 to the 1? No. Or can you just immediately go to factorization? Alright? And then this is 2 to the negative 1. So we take out the common 2 to the x, and what's left? 2 plus, I like it. 2 to the negative 1, which is a half. I'm going to go to normal numbers now, so just take them to normal numbers, equal to 5. My mission is to get this 2 to the x alone. So that I've got 2 to the x equal 2 to the something. So I've got to get rid of this multiplication. So there's variations. You can say 5 divided by this whole bracket. Or you can first go and add them and say 2 to the x times. And when you do this on a calculator, it'll give you 2.5. But the calculator will say 5 over 2, which isn't a problem. And then when I do divide both sides, it's going to be 5 divided by 5 over 2. That's what I'm doing on my calculator. And that answer is 2, which you can do with or without a calculator. But then, the answer is 1. And remember, if we have the solution of one of these questions, you can always go back to the top and say, substitute the x with a 1 there and a 1 there, and then this whole answer should add up to 5. Then you know that your sum is right. Okay. Next one, again, we're busy with exponential equations. Definitely exponential equations. And the problem is again the... So do we go and say 81 is 3 to the power 4? Is it true that it's 3 to the power 4?
Yes.
But is it going to help me? Okay, so we see the pluses and minuses, and it tells us we must factorize. But how do I factorize that?
Isn't there if you take that?
Common 3, if you take out a common 3, what's left here? 3 to the 2x minus 1, which isn't wrong. Okay, so common 3, it's not going to help me to simplify. So what else can you do? There's a 3 to the 2x. There's a 3 to the 1x. Let's split it up. 3 to the 2. So that maybe, hopefully, you see, okay, well, I'm not going to be able to take out a common factor like this one. There's too many there. So isn't something else to my disposal? K method. Because if you do put K method in, then you'll see that this is a quadratic trinomial, of which the variable is 3 to the 2x, and the variable is 3 to the x, which means this one is double that one, and the coefficient is a 1. But seeing that is quite difficult. So rather go for the K method. Then what is this equal to? K squared. You see it? Because it's K, 3 to the x times 3 to the x giving me 3 to the 2x. K squared. Minus, let's put it all together. So this will be 2 times 9 is 18. Okay, it's a lot. You first want to show yourself 2 times k times 9 and then get to 18k, that's fine. And the last 81, I'm just leaving it there for now. But at least now I've got a more decent, normal looking human trinomial, which I must be able to factorize with whichever method is to your disposal. What are the factors of 81 that will give me 18? Which you do by saying 1 times 1 and 1 times 1 is 81. There's a few of them. 1 times 81, 3 times 27, and we search. So the 1 is at the top, the 81 is at the bottom. We cross multiply, need to get to negative 18. Both of them must be negative, therefore. And these are my 2 crypt notes, or my 2 spy language methods for saying this must now be k minus 9. K minus 9. Happy on that? Yes. So that my answer for k is equal to 9. This is my little method that I don't have to show. K is equal to 9. Do we say k is equal to 9 or k is equal to 9? It's hot today or it's hot today. Okay, so k is 9, but am I finished? Because I need to go back to x. I've got 3 to the x for k, and the 9 must be 3 squared, so that my x is equal to 2. Alright, definitely very good idea to do K method here. But ma'am, I don't know when to do K method. The more you practice, the more you'll see. This is a very good idea for K method, guys, and it's not going to get easier. Okay. The next one, I put it in because of that root there. What do we do with it? Okay, so there's actually two things to do. What can we do? You said divide the exponent, so it's going to be the whole thing over 2, right? But the 9, will I change that 9? What do you think?
Yes.
Yes, because it's also going to be 3 to the x-ish something. Definitely. Am I going to take this and try and do something prime factorizing with it? For now, there's no reason, so just leave it be. Sometimes, sometimes not. That's the feeling you must get. So if I do make the 9 a 3 squared, then that will be 3 to the power 2x plus 4 divided by 2. Do you see me doing two things in one step? So 3 squared, then I time it up, and we're putting it over the root signs, which is a 2. That will give me 3 to the 1x plus 2 eventually. This one was just standing there looking nice, and the 26 over 7 as well. And then what do we do with this? You can factorize. Why do you need to factorize?
Because of minus.
Right from the start, you should have thought, I think I'm going to factorize. We are going to factorize by taking out a common factor. K method necessary? Can you use it if you want?
Yes.
But I don't think it's necessary for this one. Split it up so you can better see, or don't split it up. If you don't have to split it up, it's fine, but then you've got to know that you're not making mistakes. So that what's left here is 3 squared, which is 9. If you first want to write 3 squared, that's fine. And over here, what's left if you take out the 3 to the x? Minus 3 to the negative 1, which is a third. If that's way too much for one step, rather write down the steps. Show me that this is going to be 3 to the x, 3 to the 2. This is going to be 3 to the x, 3 to the negative 1. Show me when you take it out that there's 3 squared and 3 to the negative 1 left. Then show me that it's 9 and minus a third. You're not going to get extra marks for that, but it'll help you not to make mistakes. For this one then, I need to, please remember, timing in, all sorts of stuff that spring to mind. What's your focus? You've got to get 3 to the x alone. So this has got to go. It's been multiplied, you've got to divide. So you can first subtract this. While I didn't do that previous one like that, let me show what I actually want to see. I want to divide by, I just want to write it differently because alternative, right? So if I say divided by that 9 minus a third, is that okay? But maybe you haven't simplified it, it's okay. The end is going to be simplified. That's all I want. I need that 9 minus a third to be added. So, to be subtracted, but adding negatives is subtracting. So if I get that answer, it's what? 26 over 3. So this is actually divided by 26 over 3. Are you with me? If you do it without a calculator, you're going to say times with swapping it around. And your answer is? Come on, give me 9, 27, a third. 1 over 9. Yes. How did you get that? Calculator. Are you with me, everybody? What I'm trying to show you is the method is the important thing, that the multiplication of that whole thing was divided to get it away. So you didn't need to touch any prime factors over here. And I'm so ecstatically happy about the 9 because I'm busy with 3 prime factors. It has to be in grade 11 because you haven't done logs yet. So we got 3 to the x and 3 to the minus 2. Oh, excellent. It's so good for you to know that 3 to the minus 1 is a third. 3 to the minus 2 is a ninth. So that your answer is x is equal to negative 2. Right, I still believe you need some more exercise. So I'm going to write it down here for you. Alright, there's your homework for tomorrow.